Hi friends, welcome back to our channel. Today we are going to discuss about motion of connected bodies over pulleys. Okay, right now here we are considering two blocks which are connected with pulley. This is the pulley we are considering. Two blocks which are connected by the string which is passing over pulley. This is mass m1 and this is mass m2. Okay, here you can consider one more string thread you can consider. This is fixed position. Right now, what is the acceleration of the body m1 and m2 and what is the tension in the string? This is the question we have. Here these two are connected by one string so that they will move with the same acceleration. Okay, what is the acceleration and what will be the tension in the string? Here if the thread or the string is massless, then the tension in the string remains same. Okay, here massless string we are considering. So free body diagram we need to draw so that we can identify what will be the acceleration and what will be the tension in that. Free body diagram is nothing but the number of constraint forces which are acting on it. We need to separate the body from it. How many number of forces are acting on that, we need to identify that. We are calling it as free body diagram. Here M1 body I am considering. M1 body I am separating. How many number of forces are acting? Weight of the body is acting always in downward direction toward the center, and tension in the string which is acting toward the fixed point. So tension will be in upward direction. Here in this also tension will be in upward direction. Weight of the body is also acting in downward direction. Okay, here tension is in upward direction. Let the blocks which are moving down, this is moving down, and so that this is moving up. Okay, when they will move one down one up means here m1 body having more mass so that it will come down, m2 body is less mass so that it moves up when you released it. What is the net acceleration on this? Net acceleration will be in downward direction, so that we can write one equation on basis of this. Net force which is acting in downward direction with the acceleration a, so that m1a net force is equals to m1g minus tension T. This is the first equation for this free body diagram. And coming to second free body diagram, weight of the body is always acting in downward direction, m2g. Tension is in upward direction. Acceleration is also in upward direction. We will get one more equation for this. Okay, so net force m2a is equals to, tension will be more, but because it is going up, so tension T minus m2g. Okay, this is equation number 1 and this is equation number 2. Combined together, we will get an acceleration term. Here if you add these two equations, tension gets cancelled, so we will get an acceleration term. So I am writing m1a is equals to m1g minus T, m2a is equals to tension minus m2g. Adding both the equations, tension gets cancelled, so we can write directly acceleration a is equals to m1 minus m2 divided by m1 plus m2 into g. This is the formula for acceleration. Okay, they combine together. Here these two getting common, g common. Okay, this is the acceleration term. If you substitute this equation in any one of the formula, so one either R2. So we'll get a tension. Okay, tension T is equals to, from 2 I am taking. Okay, T is equals to M2A minus, if you send it left, it becomes plus. Tension T is equals to M2A plus M2G. Okay, so we need to substitute A value in this. Directly we can multiply M1 M2 minus M2 square divided by M1 plus M2 into G term plus M2G. If we take LCM again, so we'll get M1 M2 minus M2 square, combined together we can take G out, plus M1 M2 again plus M2 square into G divided by M1 plus M2. So that here M2 square gets cancelled. So we get tension T. T is equals to 2M1 M2 by M1 plus M2 into G. This is the tension in the string. This is the acceleration and this is the tension in the string. Okay. Let be the tension in this. I am considering it as T dash. T dash is equals to downward direction, both are in downward direction, you can consider, because toward the fixed point. So that T dash is equals to 2T we can write. Okay, so that we can write a formula 2 into 2M1 M2 by M1 plus M2 into G, so that we will get thrust or tension in the string, or thrust you can write. What is the force exerting on the roof? T dash is equals to 4M1 M2 by M1 plus M2 into G. This is one more equation. And right now, suppose if this completely system, system completely placed in the lift. When the lift is moving upward direction, what the changes happens? When the lift is moving downward direction, what the changes happens? Okay. If this is completely placed in the lift, system placed in lift. When it is placed in the lift, what happens? The acceleration due to gravity, G becomes G plus A when it is moving upward direction. When it is moving upward direction, and when it is moving downward direction, when the lift is moving downward direction, G effective becomes G minus A downward. So that acceleration and tensions will be differ. Okay. So then what happens? Actually, this concept is there in the lift. You can find it. G effective is equals to G plus A. G effective is equals to G minus A when it is moving upward and downward direction. Already we got an acceleration. A is equals to M1 minus M2 divided by M1 plus M2. Instead of G, you need to consider it as G effective. So that what happened? The acceleration formula, A is equals to M1 minus M2 divided by M1 plus M2 into G plus A when it is in upward direction. When the lift is moving in upward. Okay, when it is in downward direction, when it is going in downward direction, acceleration A is equals to m1 minus m2 divided by m1 plus m2 into g minus A. This is the formula for acceleration. What happened to the tension? Tension, it becomes T is equals to 2 m1 m2 by m1 plus m2 g plus or minus, I am writing directly for both combined together, plus positive when it is upward, negative when it is downward. Here, if the string is having mass, if string have mass, what happened to the tension? Then the tension becomes different. Then the tension becomes different. Okay, what will be the acceleration? Here, mass of the string, I am considering it as capital M. Okay, directly you can write one concept. What is that means? Here, just before, m1g is in downward direction, m2g is in downward direction. What is the difference in forces? m1g minus m2g. That gives you net force. Directly you can write from that. Okay, what is the total mass of the system? m1 plus m2 into A with acceleration m1g minus m2g. So that we will get a formula A is equals to m1 minus m2 into g divided by m1 plus m2. That is the concept. Here, what happened to the mass of the system? According to center of mass, mass becomes m by 2. So, what will be the acceleration of this? Acceleration A is equals to, directly I am writing m1 minus m2 plus, sorry, m1 minus m2 by total mass of the system m1 plus m2 plus m by 2 into g. This is the formula for acceleration. Okay, if the string having mass. And what will be the tensions? Directly I am writing for the tensions. Tension T1 in the string. T1 is equals to m1 of 2m2 plus m by 2 into g divided by total mass of the system m1 plus m2 plus m by 2. This is the tension in the string T1. Similarly, tension T2 in the string. T2 is equals to m2 of 2m1 plus m by 2 divided by m1 plus m2 plus m by 2 into g. This is the tension in the second side. Okay, these are the formulas which are related to when the string having mass. When the string having mass, then the tensions will be different in different parts. So that T1, T2. What will be the T1? Here it will be the T1. This is T2. What is the acceleration? A is equals to m1 minus m2 divided by m1 plus m2 plus m by 2 into g. This is one more. Here, if it is having mass, then what happens to the tensions difference? Okay, here according to torque, what happens to this means, here this is the disc, nothing but wheel. When it is moving then the forces which are acting on this will be downward. This is T1 and this is T2. Okay, and the radius of the wheel is R. Radius of the wheel will be R. So then the tension difference T1 minus T2 into, actually this is the formula for torque. Torque is nothing but force into radius. Okay, so tension difference T1 minus T2 into radius R is equals to I alpha, where alpha is nothing but motion of the wheel, angular acceleration. Alpha is nothing but angular acceleration. So angular acceleration and linear acceleration, we have a relation. Alpha is equals to A by R, or this can be written like A is equals to R alpha. This is the relation. From that we can write like this. So then the moment of inertia of the disk, moment of inertia of disk is giving you mass of the disk is m and r square divided by 2. So that we'll get one relation, T1 minus T2 into r is equals to mr square by 2 into a by r. Here r square gets cancelled. So we'll get a formula, tension difference T1 minus T2 is equals to ma by 2. This is the relation we have in between force, tension difference and acceleration. Two bodies M1 M2 which are connected by the string, and one is placed over the surface, second one is suspended. Here M1 is more than that of the M2. When it is released, then what happens? M1 will go downward direction and the M2 will be pulled horizontally. What will be the tension? Tension acts in this upward direction, tension acts in this direction toward the fixed point. What will be the acceleration? What will be the tension? We need to calculate. So free body diagram of M1, M1G is in downward direction, tension will be in upward direction, acceleration will be in downward direction. So that we can write a formula for this. What we can write, net acceleration, net force M1A is equals to M1G minus tension T. Similarly, if we consider one more free body diagram, M2, what will be the force acting on this? Only tension will be along horizontal direction. What will get the formula? When it is moving with an acceleration, force exerting on it produces an acceleration, then tension T is equals to M2A. This is equation number 1, this is equation number 2. So that we can substitute T value in the first equation, we will get the acceleration formula. So M1A is equals to M1G minus tension T is nothing but M2A. So bring it left. So A getting common, so we will get M1 divided by M1 plus M2 into G. This is the formula for acceleration. After getting acceleration, you can find tension in the string. So you can substitute in the second formula. We can calculate tension. What will be the tension? T is equals to M2. A is nothing but this. Already here it will be M1. We have M2. So we'll get M1 M2 divided by M1 plus M2 into G. This is the formula for tension. Okay. And coming to next pulley. Suppose if it is placed, one of the object is placed over the inclined surface, then what will be the tension and acceleration? Okay, how it will be means we can consider like this. This is the sharp edge we are considering. Here we have a pulley. This is the pulley, and over this one block is suspended, and one more which is placed over the surface. Okay, here this is the angle made, you can consider theta. M1 body and this is M2 body. Okay, here actually this is the object which is there on the inclined surface. Here what will be the tension direction? Tension upward. Here the tension in this direction. What will be the acceleration? Is in downward. This is in upward, inclined or parallel to inclined surface. Okay, according to this we have a small resolution. Here this is the angle made theta, so that M to G will be in downward direction. Here if you draw normal for this, here there is an angle theta, so this will get M to G cos theta, and here we get normal, and perpendicular to this we will get M1G sin theta. Here normal and M to G will be remains constant. It is not moving in perpendicular to the inclined surface, only along horizontal direction. What will be the force acting backward? Tension will be the force. Okay, this is nothing but a free body diagram you can consider. Okay, M1G is in downward direction, tension will be in upward direction. So what we can write, tension T is equals to M1G sin theta. Okay, now coming to M1 body, sorry M2, coming to M1 body, M1G is in downward direction, tension will be upward, acceleration is in downward direction. Okay, here you can write one term. First I will write a free body diagram for this. What will get? We will get a formula M1A is equals to M1G minus tension T. Let be 1, equation number 1. Here what is the acceleration direction? We need to check. Here free body diagram of M2 we are taking. This is M2, tension and acceleration, and M1G sin theta. Net acceleration, so what will get? M1A is equals, net force is equals to tension minus M1G sin theta. Let it be this equation number 2. Combined together we can solve that. Here this is M2, this is M2, M2, M2. Okay, M1A is equals to M1G minus tension T. Adding these two equations, so that we will get M1 plus M2 into A, we will get left side M1 plus M2 into A is equals to, tension gets cancelled, so we will get M1 minus M2 sin theta into G, getting common, G getting common. So acceleration will get A is equals to M1 minus M2 sin theta into G by m1 plus m2. This is the formula for acceleration. Okay, and coming to tension T is equals to, we can write in equation number 1 or else equation number 2. In any one of the equation you need to write and you need to calculate. So what will you get? Bring it left. So m1g minus m1a. Okay, m1g minus m1a. So what will you get? M1 square multiplying directly m1 square g m1 m2 sin theta m1 m2 sin theta by m1 plus m2. Okay, here what will you get? Multiplication again, m1 square g gets cancelled, so m1 m2 g. So we will get the formula directly. m1 m2 I am taking common, m1 m2 into 1 plus sin theta by m1 plus m2. This is the tension in the string. Okay, what will be the acceleration? This is the acceleration and this is the tension in the string. This is only two blocks which are placed over the wedge. Here this is the angle made, here is alpha, here it will be beta, and what happened? The acceleration means m1 is coming down, m2 is moving up. When it is released, what will be the tension? Tension will be T in upward direction in the both the strings. Okay, so here we need to find acceleration and also tension. So that we need to draw free body diagrams. M1 I am drawing. Actually just before what we got, the same manner. M1 in downward direction, cos sine component will be, so I am writing directly m1g sin theta, tension will be in upward direction and acceleration will be downward. Actually this is inclined. Here instead of theta we will need to take beta. Okay, just resolution of m1. How many number of forces are acting on that? We need to resolve that, so that we will get like this. Okay, similarly we can take a free body diagram of m2 m2g sin alpha, tension is in upward direction, acceleration is in upward direction, so that we will get two equations. What is the net force acting on this? Net force is equals to m1a. In which direction it is going? m1g sin beta will be more, m1g sin beta minus tension T. Let it be this equation number 1. Okay, coming to here, what will be the net force acting on this? So what will get net force? m to a in upward direction is equals to T minus m to g sin alpha. Let be this equation number 2. Combine it together, we can add, so that the tension gets cancelled. So by adding m1 plus m2 into a is equals to m1g sin beta, tension gets cancelled, minus m2g sin alpha. So we can write an acceleration formula. A is equals to g, getting common from this, m1 sine beta minus m2g outside sine alpha into g divided by m1 plus m2. This is the formula for acceleration. Okay, when they are inclined each other, so that m1 sine beta, m2 sine alpha, m1 g sine beta, m2g sine alpha, both the forces which are acting on this. Okay, so that force difference is giving you net acceleration, so that A is equals to, this is the formula we are getting. And right now we need to calculate tension. Okay, what will be the tension we need to calculate? You can substitute this formula in any one of the equations so that you can calculate acceleration. Okay, from equation number 1 I am considering, so that tension T, we need to send it left, m1g sine beta m1g sine beta minus m1a from equation number 1. Okay, what is A? A is nothing but this is the value. We need to substitute in that. This is the formula. So tension T is equals to m1g sine beta minus m1 of this complete term divided by m1 plus m2 will be. So m1 sine beta minus m2 sine alpha divided by m1 plus m2 into g. Okay, g getting common, m1 sine beta and here m1 will be multiplied, minus m1 square sine beta gets cancelled. Okay, we can substitute, we can multiply and LCM. Total LCM is m1 plus m2, multiplying this, g getting outside, we are keeping it out, m1 sine beta into m1 square sine beta plus m1 m2 sine beta. Okay, minus m1 square sine beta plus m1 m2 sine alpha. m1 square sine beta, m1 square sine beta gets cancelled. So what will get the formula for tension? Tension T is equals to m1 m2 getting common. So m1 m2 of sine alpha plus sine beta divided by m1 plus m2 into g. This is the formula for tension T. Here is the acceleration. Here will be the tension when it is in this shape. Okay. If sine theta and sine alpha, sine beta, alpha, beta both are same, then what will get? Sine alpha, or sine theta, 2 sine theta. So we'll get alpha is equals to beta is equals to theta, then tension T is equals to 2m1 m2 sin theta by m1 plus m2 into g, when both the angles are same. Okay, this is two bodies which are connected by the string. Here two pulleys are arranged, m1, this is m2. When it is released, acceleration will be in downward direction, acceleration will be in forward direction. What is the tension in this? T. Here will be the tension in upward direction. So Here we will get one more force which is acting in downward direction. According to resolution we will get, okay, I will give you here the angle made. Here it will be theta we are considering. Okay, free body diagram of M2. This is M2. M2G sin theta is in downward direction. Tension will be in backward direction. Acceleration will be in downward direction. So M2A is equals to M2G sin theta minus tension T, because downward direction force is more, so that tension will be minimum. So what happens to the free body diagram of M2? Free body diagram of M1. MT is equals to, directly we can write M1A. Why? Because only one is the force which is acting. What will be the free body diagram for this? M1, tension T, acceleration A. So that we will get T is equals to M1A. It will be this equation number 1 and this equation number 2. Substituting this in the formula, so M2A is equals to M2G sin theta minus M1A. Bring it left so that we will get the acceleration formula. M2G sin theta by M1 plus M2 into G. This is the formula for acceleration. What will be the tension? Tension T is equal to, we can substitute in this formula so that we will get the formula for the tension. Tension T is equals to acceleration. We need to substitute in this. So M1, remaining term M2G sin theta. So M1 M2 divided by M1 M2 sin theta divided by M1 plus M2 into G. This is the formula for tension T. Here we have one more diagram, pulley diagram. M2 is on the surface, M1 is suspended, and here we have a pulley, and here we have one more pulley. What is the tension in the string? Tension in the string is T, same string, so the tension remains constant, and acceleration of this is A2 and acceleration of this is A1. Why? Because the strings are different. What is the tension in the string in the second one? T and T. Combine it together, we will get 2T. Okay. Here we will get the acceleration relation. Just I will give you one idea. If the block moved by x distance, how much distance this block will move? Means x distance left side and x distance right side. Why? Because it is, when it is going down, then what happens? The distance here, it will be x distance is moving. So what happens again? One more x distance will be. So 2x distance will be. So what will get? 2 times that of the acceleration A1 is equals to A2. Why? Because if we differentiate it 2 times, then we'll get the acceleration relation. Okay. So A2 is equals to 2A1 we are getting. And the free body diagram we are considering for M1, M1G, tension 2T is in upward direction, acceleration downward. So we'll get the relation for this. M1A1 is equals to M1G minus 2T. Similarly, M2 we can take tension T only acting, acceleration A2 is forward direction, T is equals to M2A2, and A2 is nothing but 2A1 we can substitute. T is equals to M2 of 2A1, and we can substitute third equation in the first one so that you can calculate acceleration A1. A1 body acceleration will get. So M1A1 is equals to M1G minus 4M2A1. Why? Because T is equals to 2M2A1. Okay. Already 2 will be there. So we'll get 4M2A1. Bring it left. So that M1 plus 4M2 into A1 is equals to M1G. So the acceleration A is equals to M1 by M1 plus 4M2 into G. This is the formula for acceleration A1. so that you can calculate acceleration A2. A2 is equals to 2 times that of the A1. So 2 A1, A1 is nothing but this, so we'll get A2. A2 equals to 2 M1 divided by M1 plus 4 M2 into G. This is the acceleration of the second body. First body acceleration, second body acceleration we got. Okay. You can calculate tension. Tension, what will be the tension in the first string? If we'll double it, we'll get the second string. So you can substitute tension T. T is equals to M to A2. So you can substitute directly in the second. Okay. T is equals to M to A2. A2 value is this. So tension T is equals to 2 M1 M2 by M1 plus 4 M2. What is this? This is the tension in the first string. If we double it, we'll get the second string tension. I think M1, M2, M3. Three bodies are there. One block is placed over the surface. Remaining two are suspended over the table. What is the tension in this? Tension T1 I am considering. Here also we have a tension T. Forward and backward we'll get. Here what will get the tension in this second string? T2. Forward, backward tension T2. Suppose if you release it, M1 block is coming down with an acceleration A. Here this is moving with an acceleration A, and this is moving with an acceleration A in upward direction. So first you need to draw free body diagrams. M1, M1G, tension T is in upward direction, acceleration will be in downward direction, so that M1A net force is equals to M1G minus tension T. Number 1. Okay. Second, coming to second free body diagram, M2. Here is the M2. Weight is downward. Tension T is in upward direction. Here this is tension we consider T1, so that this is T1. Here this is T2 we consider. So what is the acceleration which is going up? So what will get net acceleration, net force M2 A equals to T2 is maximum than that of M2 G. So that this is equation number 2. Okay. Coming to third. Free body diagram of M3. So the tension which is right side is T1, the tension which is left side is T2, acceleration is in forward direction. So we will get the net force M to A is equals to T1 minus T2. This is number 3. Okay. Here T1 is there, here T2 is there. Combine it together, you can substitute in this third equations. So M3A, T1 I am writing. T1 equals to M1G minus M1A. M1G minus M1A minus of T2. You can send it left. So what will get? Minus M2A minus M2G. Minus M2A minus M2G. So M1A1, M1A, M2A. Send it left. So what will get? Acceleration getting common. So M1 minus M2 into G. G getting common. So what will get? M1 plus M2 plus M3. This is the formula for acceleration of the system. Okay. Here you can calculate tension in the strings. Okay. If you substitute in first equation and the second equations, you can calculate the tension formulas. Okay. Tension T1 is equals to, bring it left, send it right. So m1g minus m1a. A is nothing but this, directly I am substituting m1 minus m2 divided by m1 plus m2 plus m3 into g. From these to g getting common again. So here m1 square will be, here also we'll get m1 square will be. So what happens? They get cancelled. Okay, we'll get the relation for that. Then tension T1 is equals to m1 square multiplying m1 m2 and multiplying m1 m3. G I am keeping it out. So m1 square minus of minus, it becomes plus m1 m2 into g divided by m1 plus m2 plus m3. m1 square gets cancelled. So in all the terms m1 is common. So tension T1 is equals to m1 of 2m2 plus m3 into g divided by m1 plus m2 plus m3. This is the formula for tension T1. Similarly, you can write tension T2. We will get directly m2 of 2m1 plus m3 into g divided by m1 plus m2 plus m3. Okay, this is giving you tension relations with acceleration.